Our third strategy for algebraic limit problems is going to focus on problems that have a square root. And let's refer to this technique as rationalize the radical. So the facts that we're going to build into this come from the idea that in general, things involving square roots are considered to be irrational. And one of the facts that we learned early on in our study with radicals is if we multiply the square root of a number by itself, by definition, we end up with a rational term. This changes a little bit for other kinds of roots like cube roots and fourth roots, but we'll be dealing here with square roots. And so we have a fact that the square root of a number times itself gives us a rational. You may remember that there were issues with problems early on, like this irrational number represented by the square root of 5 plus 3. If we wanted to turn that into a rational value, it doesn't work anymore to multiply it by itself. Let's work through the steps really quickly. The square root of 5 times the square root of 5 is in fact rational, but we also have this product over here, the square root of 5 times 3. This expression right here, 3 times the square root of 5 also, and finally 3 times 3 gives us 9. So in the end, what we get is 14 plus 6 times the square root of 5. And that didn't resolve our problem of giving us a rational expression. So instead, we've got another strategy, which we use for binomial terms. We're going to multiply the square root of 5 plus 3 by something we refer to as its conjugate. You might remember conjugates in the context of radicals. You also saw conjugates in the context of imaginary numbers. And the radical conjugate is essentially the same expression where the terms are subtracted rather than added. And here's what we're going to see. When we work it out, we'll still have the same products. Radical 5 times radical 5. But check out this difference. Radical 5 times negative 3 gives us minus 3 root 5. On the inside, 3 times radical 5 gives us plus 3 root 5. Can you see what's going to happen when we simplify? And 3 times negative 3 is minus 9. And lo and behold, we end up with an expression which is just a rational number. So we're going to take advantage of the fact that when we're dealing with problems involving radicals, we can fix a lot of those problems using this strategy.